Before you walk into your next 5G new radio RF job interview, make sure you can answer these 20 real questions asked by top telecom companies. If you get this right, you are already ahead of 90% of candidates. Welcome back to the channel. Today, we are covering one of the most requested topics, top 20 interview questions for 5G new radio RF engineers. These are real questions asked in RF design, optimization, and testing roles across operators, vendors, and test and measurement companies. Let's get started. Question 1. What is link budget? Link budget is the complete end-to-end calculation of all gains and losses in the radio path, from the transmitter all the way to the UE receiver. It helps determine whether the received signal will be strong enough for reliable communication. Question 2. What affects 5G new radio link budget? 5G new radio link budget is determined by transmit power, antenna gain, path, and hardware losses, required modulation, data rate, beamforming gain, bandwidth, and receiver noise figure. In 5G, beamforming significantly boosts link budget compared to 4G. Question 3. Explain SSB in 5G new radio. The synchronization signal block, or SSB, carries PSS, SSS, and system broadcast information. 5G beam sweep the SSB across multiple directions, so the UE can detect the cell and select the best beam. Question 4. 4G versus 5G beamforming. Differences between 4G and 5G beamforming. 4G mainly use fixed, wide beams. 5G introduces massive MIMO and dynamic beamforming with narrow, directional beams that adapts to UE movement, improving signal quality and throughput. Question 5. What is new radio numerology? Numerology defines the subcarrier spacing. 5G supports scalable spacing from 15 kHz to 480 kHz, depends on the frequency band, FR1 or FR2, enabling flexible deployment for low latency, high bandwidth, and millimeter wave carriers. Question 6. Explain RSRP. RSRP is the average received power of specific reference signals and is widely used as a coverage metric. Question 7. Explain RSRQ. RSRQ combines RSSI and RSRP to indicate signal quality relative to the total power and the interference in the channel. So, high RSSI could indicate high interference, not necessary for wanted high RF power. 5G RSRQ range is defined as -43 dB to 20 dB. 5G RSRQ can be a positive or negative value, whereas LTE RSRQ is always a negative value. Question 8. What is SINR? SINR stands for signal to interference plus noise ratio. Higher SINR means cleaner signal quality, enabling higher throughput and better user experience. Question 9. What impacts SINR? The key factors impact SINR include interference, receiver noise figure, beam alignment, and overall propagation conditions. Question 10. What is CQI? CQI, or Channel Quality Indicator, is reported by the UE to recommend the optimal modulation and coding scheme. Higher CQI means the network can schedule higher data rates. Question 11. Role of MIMO. MIMO uses multiple antennas to increase capacity improve reliability, and then extend the coverage. Massive MIMO, one of the biggest 5G innovations, supports many parallel spatial streams and an advanced beamforming. Question 12. Explain PA and an LNA. PA, power amplifier, increases the transmitter power to the required level. LNA, the low noise amplifier, boosts weak received signals while adding minimum noise, preserving sensitivity. Question 13. Role of filters. Filters allow only desired frequencies to pass and reject unwanted bands, reducing interference and meeting emission requirements. Question 14. What is drive testing? Drive testing collects real-world measurements of coverage, quality, throughput, and beam performance. It's critical for verifying network performance and optimizing 5G deployments. Question 15. What are the 5G drive test KPIs? The key KPIs include RSRP, RSRQ, SINR, block error rate, throughput, and beam metrics such as beam index, beam switching, beam signal-to-noise ratio, and beam CQI. Question 16. What is block error rate? Block error rate measures decoding errors. High block error rate indicates poor link quality and limits throughput. Question 17. What is TDD? Time division duplex uses the same frequency band for uplink and downlink, but separates them in time slots. Question 18. Why TDD for 5G? TDD enables flexible uplink and downlink ratio, supports massive MIMO architectures, and aligns well with 5G's beamforming and high bandwidth needs. Question 19. What is over-the-air testing? Over-the-air testing evaluates the radiated RF performance of a device or G node B in a chamber environment, including beamforming, radiation patterns, and throughput. Drive tests are over the air in the literal sense because there is no cable. However, the telecom industry uses over-the-air testing specifically to mean chamber-based environment RF testing. Question 20. What do interviews look for? Interviews care about more than just memorized answers. They look for strong RF fundamentals, ability to interpret KPIs, real troubleshooting experience, clear communication of complex ideas. If you can explain concepts simply, you are already ahead of many candidates. And that's all for today. If you like this video, please subscribe, share, and like. Thank you.